In this video, we'll review the order of operations and evaluating expressions. But first, we'll look at simplifying powers, because we know exponents are part of the order of operations. So a power is a number that can be expressed using a base and an exponent. In A, 8 is the base, 3 is the exponent. 8 to the third power, that means 8 times 8 times 8. I know 8 times 8 is 64. And then 64 times 8, 512. Now look at B and C. Think about what's different about those two, and then we'll see how we approach those two problems differently. So for B, I think about this problem as, this is that quantity, -3 to the fourth power. So that means I'm going to multiply a -3 4 times. Well, -3 times -3, that's +9. -3 times -3, that's also +9. And 9 times 9 is 81. But see, we're not going to get the same answer. So because that negative sign is not in parentheses, one way you can think about this problem is, what is the negative value of 3 to the fourth? Or what is the opposite of 3 to the fourth? So I'm going to think about to myself, what is 3 to the fourth? 3 times 3 times 3 times 3. Well, we know that's 81, but I need the opposite value of 81. So C is -81. And then for D, this is 2/5 to the third power. All that means is we use our base 2/5 as a factor 3 times. When we multiply fractions, multiply the numerators, 2 times 2 times 2, that's 8, and then the denominators, 5 times 5 times 5, that's 125. Here are some for you to practice on your own. 4 to the third power means 4 times 4 times 4. 4 times 4 is 16, and 16 times 4, that's going to be 64. Let's look at B. This quantity, -2 to the fourth, -2 times -2 times -2 times -2, -2 times -2, +4, -2 times -2, +4, 4 times 4, +16. But now for C, this is the opposite of 2 to the fourth. 2 to the fourth is 2 times 2 times 2 times 2. Which is 16. But I want the opposite of that. So it's -16. And then finally, 3/10 to the third is just 3/10 times 3/10 times 3/10. And that is going to be 27 1/1000ths. Okay, let's take a look at the order of operations. We perform any operations inside grouping symbols, such as parentheses or brackets, squiggly brackets, and absolute value. That's what this is here. A fraction bar also acts as a grouping symbol. You would simplify everything in the numerator and then everything in the denominator. Then we'll simplify the powers, the exponents, or if there's the square root symbol. Remember, we multiply and divide from left to right. We do not just always multiply first. It depends on what comes first, left to right. And then we add and subtract also in order from left to right. So in this expression here, the absolute value of 4 minus 3 to the fourth, and then there's the 2 after that. Remember, that means we're going to, whatever that absolute value is, we're going to multiply it by 2 over the square root of 100 minus a -1. So first I want to look in my grouping symbols. 4 minus 3 to the fourth. In that grouping symbol, what do I have to do? Do I subtract or do I raise to a power? And of course, we're going to raise to the power first. So 3 to the fourth power, 3 times 3 times 3 times 3. And that is going to be 81. And then I'm going to copy everything down. Mathematicians communicate their thinking clearly. So I'm not going to try to do too much in my head. I can take the square root of 100. What number times itself is 100? That's 10. And let me just make this easier to look at. Instead of writing minus -1, I'm going to write +1. So now I'm going to do 4 minus 81 because I still need to simplify in those grouping symbols. 4 minus 81, that's negative 77. And then I'm going to multiply that by 2. The absolute value of negative 77 times 2. And then that's going to be over 11. Well, what's the absolute value of negative 77? The absolute value of negative 77 is just 77. And then 77 times 2, that is 154. And all of that's going to be divided by 11. And what is 154 divided by 11? That will be 14. All right, here's one for you to try on your own. So first, I've got this negative 8 here. I look at my numerator. I am going to take negative 4, that quantity, and square it. Well, negative 4 squared is 16. And then I want to write whatever is left in that numerator. And now in the denominator, I'm going to take what's in my absolute value. Negative 14 plus 8, that's a negative 6. But I got to remember those absolute value signs are there. So the absolute value of negative 6 plus 1. Well, here I can do 16 plus 5 because I want to simplify what is in my numerator. So 16 plus 5, that's 21. The absolute value of negative 6 is 6, plus 1, that's 7. And then just don't forget that negative 8 we had hanging out there at the beginning. Now I've got negative 8 plus 21 over 7, right? Fraction bar means division, so I'm going to divide next. Negative 8 plus 3, that's negative 5. Now I want to evaluate these expressions. All that means is I have variables in my expression. I'm going to take out those variables and replace it with the numbers that are given. So xyz over y squared. First step, substitute. Take out the x, put in a 6. I'm going to multiply that because two variables together means you multiply. 6 times negative 3 times negative 5 over y squared. Well, y is negative 3. That means you've got to have negative 3 squared. So remember, that's going to be y times y, or negative 3 times negative 3. That's why that's in the parentheses there. So 6 times negative 3, that's negative 18. And then negative 18 times negative 5, that's going to be positive 90 over the quantity negative 3 squared. Negative 3 times negative 3, that's positive 9. 90 over 9 is 10. All right, try this one. First step is going to be to substitute. So take out the x, put in negative 2/5. Take out the y, put in 7/4. All of that squared. And then you're going to divide it by negative 2/5 times 7/4. Well, according to the order of operations, I should simplify what's in the parentheses first, right? I'm not going to square. I'm going to simplify in the parentheses. So let's cross reduce to make our multiplication easier. So I've got 1 times 7 is 7. 5 times 2 is 10. But this is a negative value. And I'm squaring it. Divided by, and since I did all that good work there, and this is the same problem in here, we know that this is also going to be negative 7/10. All right, negative 7/10 squared. That means negative 7/10 times negative 7/10. That's positive 49 over 100. Divided by negative 7/10. Now, Did you keep, change, flip here? Possibly. But do you notice in this problem, we could just divide straight across. 49 divided by -7. That's -7. And 100 divided by 10, that's 10. Right? I have a positive fraction divided by a negative fraction, so my answer should be -7/10. And that's how we evaluate expressions and use the order of operations.